multi-step algebra equations with fractions. My common denominator here is 3, so this is pretty straightforward. I'm going to multiply every term and part by 3 over 1. The 3's cancel. And I'm left with 1 times 2, which is 2, and 1 times 1x, which is 1x, or just x, and this is equal to 1 times 1, and that is equal to 1. Some kids will think that this is just 0 at this point, but remember, we're not adding, we are multiplying. 1 times 1, 1 times 1, 1 over 1 is equal to 1. So now I have numbers and I have variables on each side. When my constant is in front of my x, I find it helpful to just rearrange so that my variables come first and my constants come second. Then it's more obvious to me that I have an addition here that I want to undo, and I'm going to undo the addition of the 2, so I'm going to subtract 2 from each side. These are going to cancel, and on my left hand side then I'm left with x plus 0, which is nothing. So that just gives me an x, and on this side I have 1 plus a -2, and that gives me -1. So my answer is x is equal to -1. Number 2, 1/3 times the quantity x plus 27 is equal to 4. Now we're using fractions again here, but notice that we are now introducing parentheses. We have an expression inside parentheses, and outside of the parentheses we're multiplying by a fraction. When this occurs, there's 2 ways to do it, and I'm going to show you both ways, one over here and one over here. The first way I'm going to do it is I'm going to distribute the fraction through the parentheses and multiply each part within the parentheses by the fraction. So I'm going to get 1/3 times x is 1/3 x plus 1/3 times 27 is 27/3. Now that is just equal to 4. This 27/3 can be simplified. 27 divided by 3 is 9. This is still 1/3 x is equal to 4. So I do have a denominator here. So in order to not have that denominator, well, before I multiply everything by 3, let's go ahead and subtract 9 from both sides, because that could make the problem even simpler. So this sums to 0, and when I simplify it, I'm left with 1/3 x is equal to a -5. So you know that I can get rid of this in 2 ways. I could multiply by the reciprocal, or I could multiply by just the denominator. And actually, by multiplying by the 3 now, that actually is the reciprocal if I put it over 1. So we can think of it just like that this time. And these are going to cross cancel, and I'm going to have 1 times 1 times x, which is just going to give me 1x is equal to negative 15. And that's one way to solve it. So we'll see. We had the original problem, this step, this step, this step, and this step. 5 steps. Another way to solve this, when you have a fraction outside of parentheses. We can, to avoid dealing with this fraction, we can multiply this side by the denominator, 3, and we can multiply this side by the denominator, which is 3, or 3 over 1. These will cancel, so I'll just have 1 times 1 and 1 times 1, and so that simplifies to just x plus 27 times 1, which is just x plus 27. And on the right hand side, I have 12. So now my problem really is just x plus 27 equals 12. So here's my first step, here's my second step, here's my third step. I'm going to subtract 27 from each side. This is going to sum to 0. It's going to be gone. So I'm going to get that x is equal to negative 15. So that was 3 steps. This one is 5 steps. Either way will work. I'm going to be demonstrating the right-hand side throughout this when I do have parentheses. I want to show you why that works. We said that x is equal to negative 15, so I'm just going to come down in here and substitute that negative 15 in for x. Now you'll remember what I did was I multiplied this side and this side by 3. Remember, this is a multiplication problem. So this is looked at as one factor that I'm multiplying by, and actually this is the second factor. This whole thing is the second factor. So what I'm doing is I'm just adding an additional factor out here by multiplying by the denominator, and if I do that on that side, I have to do it on this side. That just simplifies this whole thing again down to a 1 times 1 times, so I have 1 times whatever negative 15 plus 27 is, and that should equal 12. So negative 15 plus 27 is going to equal 12, equals 12. These are all just factors in a multiplication problem. So the fact that I'm doing this multiplication first doesn't change what's going on in here. So that's why when you have these parentheses and you have a fraction on the outside, you are more than welcome to distribute that fraction throughout and work through it. It takes several more steps to do it that way. Number 3, negative 3/4 plus m equals 5/2. Now in this one I do not have any multiplication going on. I just have an addition on the left hand side, and again I'm going to switch these. I'm going to put my m first, plus a negative 3/4 equals 5/2. Now I see again that I have fractions, so I'm going to multiply everything by my least common denominator, and I have 4 and 2, so I'm going to start with my largest denominator and ask myself, is the other denominator a factor of 4? Well, yes it is. So that tells me I can use 4 as the least common denominator, and I'm going to multiply every term by 4. And when I do that, I'm going to get 4m plus, and you can see these are going to cancel, so I'm going to have plus a negative 3 is equal to 2 divided by 2 is 1, 4 divided by 2 is 2, 5 times 2 is 10. So now I have 4m plus negative 3 equals 10. Well, I have an addition here, and I'm adding negative 3. So to undo that, I'm going to just add 3, because that's the opposite of negative 3. So these two add up to 0. And if I do that on this side, I have to do it on the other side. So that means I have 4m is equal to 13. Divide each side by 4. And that leaves me with m is equal to 13 divided by 4 is 3 1/4. If I wanted to do that with decimals, 13 divided by 4, I would have to add my zeros on. And that would be 3 25/100, because that's what 1/4 is equal to.